Good afternoon, everyone. Welcome to the Center for Policy Research. Um, this is the fourth of our Clearing the Air seminar series on Delhi's air pollution. The initiative for this series has been taken by the Initiative on Climate, Energy and Environment, but folks from across CPR have engaged with it, seeing as all of us are fairly concerned and emotional about the air pollution issue. The main sort of thrust of this series is to inform the public understanding around the issue, around data, impact, sources, and policy challenges involved with clearing Delhi's air. And also an imperative on what changes are needed and what is possible to do and how we can get it done. So I'm just sort of picking out the points, what was driving us to do this. The previous panels that we've had, we've talked about sources overall of data, and we've talked about health effects. Especially, we had an entire lecture on the effects on birth outcomes. But a lot of the discussion has been around how the air pollution issue is not an episodic issue, but a chronic issue. Today's budget speech alluded to the stubble burning and sort of focused on that as an issue. And again, we know that all our speakers who've come till now have stressed again and again on the fact that Delhi is polluted the year round, and it's not just about the times that stubble is burning and there's smog and that it's visible. So, in that light, today's panel on transportation sort of focuses on one of the sectors that we know is there the year round. It's growing. Motor vehicles is an issue in Delhi, but also the whole transport sector, not just cars, but all of it, is something that we rarely think about holistically, and we rarely think about in connection to pollution as such. So I take great pleasure today in inviting our panelists on board, particularly because it's the first time they're coming to CPR. So special welcome to all of you. I've known two out of three panelists for a while, but I didn't realize that they hadn't actually visited CPR. So it's really great to invite Sumit Sharma, Partha Boshu, and Amit Bhatt to this panel on the role of transport sector in Delhi's air quality, and we want to focus on the key drivers and the opportunities for interventions. So how we'll do this is this. We'll start with Sumit. Sumit is a fellow and associate director of the Earth Science and Climate Change Group of TERI, and he's worked on projects related to air quality management, air quality monitoring, emission inventorization, modeling, and drafting air quality management plans. You've already received the mailer with the longer bios, so I won't read all of it. But essentially, Sumit will go first today with a 10-minute odd intervention, looking specifically at the source composition from transport with a focus on Delhi NCR. After Sumit, Partha will come on board. He is the lead consultant on air pollution with Environment Defense Fund, which is based in the US. And he used to be associated with the Society of Indian Automobile Manufacturers, with Clean Air Asia, and with several other government as well as UN groups. So I've asked Partha today to speak more on the fuel types, the emissions, what are the drivers for change in that sector, and also address a little bit the issue of freight, which is what he's working on currently. And we hadn't hoped to get in somebody who's so multi-talented, so we're glad Partha can actually also touch on the freight issue, which is something that often gets left out of conversations which try and look at air quality in the urban space. And last but not the least, I'll call in Amit. Amit Bhatt is the Director of Integrated Urban Transport at WRI India, and he provides vision and leadership to a number of transport initiatives across India as well as neighboring countries. I've known Amit for a while, and I know that his strong point is really looking at transport policy in a holistic way. But seeing as WRI India also does a lot of intervention work across the country and in Delhi as well, as I understand, he can also sort of not just talk policy from a policy making perspective, but also speak from their experience of working with governments and other kind of actors on the ground. So, without any hesitation, could I invite Sumit to take the lead? Sumit, do you want to move up front, or would you rather present from here? Yeah. So what we'll do is we'll make the presentations from here, and then when the discussion starts, we'll move up front so that it's sort of easier to conduct that.
Thank you so much, Mukta, and thank you for giving me this opportunity to be here and have some interactions with you. And of course, this is my first time to CPR. I love the location, beautiful surroundings. Uh, okay, let's. Sorry. Not for too long. Okay, I heard about what's happening in the surroundings. Yeah, I pray it doesn't happen. So let's start this. We are here discussing about an invisible enemy, and we at Terry are into trying to understand what this invisible guy looks like, what kind of hands he has, how many hands he has, what kind of weapons he has, how he can really impact you or kill you in the long run. So we are trying to assess all this because we cannot see him and come up with solutions to kill him eventually. So this is the broad scope of things which we look at. So we start with energy consumption and which relates to the emissions of pollutants of different types from different sources. So these pollutants could be in the form of particles and particles of different sizes. Our human hair is about 60 micrometer, and we are here talking about particles which are 10 micrometers or 2.5. And why 10? Because our nostrils will block anything which is more than 7 micrometers. So more than 7 micrometers are not so important for our human health. But finally they become more and more deadly for human beings. Other than particles, you have gases. You have oxides of nitrogen, oxides of sulfates, carbon monoxide, and VOCs. So NOx, NMVOCs, SO2, they can also convert into particles when they combine with ammonia. And they also, add to the mass of PM 2.5, which we, generally refer to. Other than these, there are a pool of gases which are called greenhouse gases, and generally a lot of people misunderstand them as pollutants. But some of them are actually pollutants also. So some particles which are black in color have both the properties. They can pollute the air quality and they can also warm the planet because they can trap the heat in the atmosphere. Accordingly, the impacts are widespread. It starts with human health because they are the first ones who are exposed to it. Then it starts impacting buildings around, and in India it all started with the famous case on Taj Mahal, and now we are hearing something happening in the Golden Temple, and there is some deterioration of the metal. Agricultural impacts. There are pollutants like ozone, which bleach the chlorophyll in the leaves and hinders the photosynthesis process and reduces crop productivity. And above all, there is impact on climate. And we are not just talking about greenhouse gases here. The impact of climates due to aerosols present in the atmosphere. Just a few statistics to see that virtually wherever you go in India, 70 to 80% of our cities are not meeting the prescribed national air quality standards. This horizontal line is the annual average standard, and you can see almost all the cities, except few in northeast and in south, are violating the standards. And we must know that our standards are quite relaxed in comparison to the WHO guidelines. So this says 60 micrograms, but the guideline is about 10 micrograms. So what we are breathing is not really good for human health. In terms of oxides of nitrogen, you can see that there is not much violation in terms of number of cities, but it is growing. And NOx is generally produced when you have high temperature combustion. So if I burn the matchstick, it will not produce so much of NOx. But if combustion happens within a engine where compression is so that the temperature goes really high, then the NOx is produced, and that's really a harmful gas. NOx just not impacts human health, but it also makes ozone in the atmosphere after combining with VOCs. And as I said, ozone is something which retards the crop productivity in India. This is the PM10 trend in Delhi, and this I started from 1999, And you can see there is a small dip till the year 2006 because you took a lot of measures during those times. You introduced new vehicle emission norms, CNG, metro, you banned a lot of vehicles, you shifted industries from the heart of the city to some other places. Of course, wrong places, I would say, and I'll come back to that once again. But after that, it grew like anything, and it reached the levels which were unprecedented. You never had the levels of 250 micrograms annual average for PM10, and 250 gram annual average means the highest levels could be 800 micrograms in some part of the year, and that has sustained for last 4 or 5 years. And that is why Delhi, that Delhi really came into the limelight that the air quality is not really good. Now you saw some sort of dip in PM10, but you cannot see a real dip in NOx concentrations. That means the efforts you put in for control of pollutions were more focused on PM10 during that era, but NOx remain uncontrolled. So that means the secondary particulates are getting formed, at the same rate without any stoppage, because NOx is freely available in the atmosphere. Now, other than the annual averages, we must see this, and actually I don't have to show this. We all know what happened in October and November. The levels reached to 800 micrograms, and this is for PM 2.5, and that actually led to the havoc, and we all started talking about it. The odd and evens came into the picture and whatnot. So that really, the only good part of this was that really brought the issue in the limelight, and we all started speaking about it, not just about it, but also about its solutions. We must also see from where the contributions are coming towards PM10 and PM 2.5. Now, if you see this, you'll find that this blue portion, which is the contribution of transport, is actually in the range of 10 to 20% in PM10, except Chennai, which is showing higher value. I was part of the Bangalore study, and it showed around 20% of PM10 contribution from transport sector. But if you shift your focus to PM 2.5, the share of transport sector immediately increases. That means transport, vehicles are emitting particles which are finer in size and are more deadly for human health. You can see that the contribution in Bangalore reached up to 50%, and in Delhi it is in the range of 20% as per the study. Now, this is the latest information we have apportionment in Delhi. This is the popular IIT Kanpur study, and it clearly showed that vehicles are contributing to about 25% in winters and 9% in summers. But there is something which we always forget in this chart, is the chunk of secondary particulates. If you see in the winters, it is 30%. Now, secondary particulates can either be nitrates, can either be ammonium, or they can be sulfates. Now, the nitrate part of it is actually, some part of nitrates is contributed by vehicles also. So, the share of vehicles is not just 25%, it is 25% plus nitrates in the secondary portion, and same in summers. But then there are so many other sources. So clearly, vehicles is one of the major source, but it's not the only source if you really want to improve air quality in Delhi. So, as I said, we just focus on PM, and we generally forget other gases. If you see NOx emissions in Delhi, in India, transport is the major contributor. Parthan, we were talking about national level study released by IIT Bombay, which said that the contribution of transport at the national level is less than 5%. But if you see the contribution of NOx, that would be much, much higher in the national scenario. So, as I said, these gases are important. They convert to secondary particulates. NOx and VOC can also form ozone, and that's also need to be looked at. The black carbon, which is an essential part of PM 2.5 released from vehicles, is a significant warming agent, and that also needs to be considered when we make decisions. So let's see what are the improvements which have happened in transport sector in last 10-15 years, and what are the remaining issues. So good news is that we have moved a lot. Our vehicles are not as polluting as they were 15 years back, because we have moved from Euro 1 equivalent standards or pre-Euro standards to Euro 4 into 2017. And if you know, India is probably the first country which have announced that we will skip Euro 5 and move to Euro 6 norms by 2020. We have introduced the fuel efficiency standards, although a lot of delay happened in that. You have introduced better public transportation systems in terms of metro rails, but still bus-based transport system is the key, which is not really up to the mark. We have introduced some sort of inspection and maintenance system, although I'll come back to this again, saying that it's an eyewash, but still we have introduced a system which is, you know, trying to make some sort of an impact. Now these graphs are showing us that what impact these Euro 6 norms are going to bring to India. So this is the emission level of vehicular sector in 2010 in India. This can go up to 282, so 2.8 times in the year 2030. But if you introduce Euro 6 norms, it will go down to almost the same level which we have today. So despite introducing Euro 6 norms, you are going to have the same vehicular emissions in 2030. So that means a lot more things need to be done. And of course, the cost and benefit, this is what we provided to the Auto Fuel Policy Committee, which took this decision to tell them that the benefits of this are much, much higher than the costs. So these are the issues which I have listed in transport sector, and I know Partha and Amit are going to talk about a lot of them. We know the declining share of rail-based freight and passenger movement in India, the declining share of NMTs. As the cities are growing, they are moving away from the non-motorized ways of mobility to motorized ones. Inadequacy of the public transport. We are still talking about 10,000, 12,000 buses in Delhi. I don't know when we are going to get them on road. The inadequate inspection and maintenance system. The current system, it is there. We have to go for PUC test. But we'll be surprised to know that only 30-40% people are going for these PUC tests. Rest all of them are not going. And whoever is going is actually getting a certificate by so many other means. You know, what I'm trying to tell you is that the testing which is done there is not adequate to control pollution from the tailpipes. There's no fleet modernization system. There's no scrappage program. If I have to, get rid of my 15-year-old car, I'll just think of reselling it, because there is no scrappage center where I can take it and get it, get the recovery out of it. There are limitations in mechanisms to promote public modes of transport, and of course electric mobility. We are all talking about it, but where is the infrastructure to support it? So I think this all needs to start. There is some issue of the driving cycles also, and it has a link with the congestion. So cars are not meant to be driven at 10, 15 kilometer per hour. They are meant to be driven at least 25, 30 kilometer per hour. So whatever you do, they will emit much, much more when you drive them at very low or very high speeds. So congestion is something that also needs to be tackled. In INM, I have limited time, but there are a lot of issues, and the time has come that we should move on from this age-old PUC testing system to more advanced OBD-based system. So new cars are fitted with a onboard diagnostic systems that can actually tell you what are the problems in the car, and you can correct it accordingly. This is my last slide, and this is what I pitch for, and why? Because in the 25% plus vehicular share, the major chunk is from the older vehicles. You have 60 to 70% of emissions from vehicular sector are coming from vehicles which are pre-2010. So that means you need to sort of modernize your fleet in the long run. And this can be done by developing a fleet modernization program which has incentives and disincentives. You need to provide incentives so that people can buy newer vehicles, and should try to disincentivize them so that they stop using the older models in their hands. I think two other speakers have a lot of information on this, and they'll be sharing it. So let me just stop here and look forward to the further. Yeah. Thank you.
Yeah. Thank you, Sumit. Partha, can I ask you to take over?
Yes.
it? Yeah, you can close it also. So, my name is Partho. I work on air pollution and emissions. This has been my area of work for last couple of years. Um, I have been a little unwell, so I'm going to stand and talk because otherwise I might doze off. And okay, yeah, sure. I will still stand. No, it's okay. Coffee has coffee is good. So, Mukta conveniently found me as a cupid between Amit and Sumit. So I'm supposed to do the marriage between transport, air pollution from transport, and urban transport, urban traffic, urban planning, etc. So I'll try to do my justice with that. So my presentation says that if there is a relationship at all between transport and air pollution, and this how does it go down? I'm sorry. I don't know. Is it stuck? No, no. So we just restart this presentation. Sure. So I actually lost 25 seconds, Mukta. I'm going to get that. Is it? Are this blank? As in, I think we should be. Oh, okay. That's good. That's good. Oh, perfect. So I was just trying to. I didn't have a presentation in the beginning, so I was just trying to see if I can make a little bit of bring a little bit of a clarity in how transport actually plays a role. So I was looking at transport and what exactly does it bring along. So I have here three parts. So one is the energy, the fuel, which basically runs the transport. Second is the engine or the technology, which basically, yeah, gives it the momentum, and also the presence by being present as it is on the road. Now, when it comes to the fuel, there has been a lot of discussions with the renewable ones and etc etc, but traditionally if you look at fuels and when people do talk about which fuel is better, I think if you look at the molecular structure of these fuels, you'll find they're very, very similar. There are few factors which goes up and down, few numbers which goes up and down, and few more new constituents which come out, but otherwise they're very, very similar. So if you are talking about debating between which of the petroleum based fuel is good, I think that discussion is an analysis paralysis which has left us a decade, and I think we have to leave it behind now and move ahead because this is not going to help much. What remains in the discussion, though, is the quality issue. The quality is an issue because I feel that in our country, what we get is approximately only 15 to 20% of the fuel is the good quality fuel that we get. Rest of the fuel are adulterated in some or other way. I will show you in next slide, subsequent slides, how does it happen. When it comes to the technology, and we talked about the emission standards, Sumit talked about the emission standards. The emission standards, up to a large extent, takes care of the fuel type, the fuel characteristics, making them more refined. And same with the technology of the engine. We get a more refined and a better engine. But what about the efficiency? The efficiency is something which exactly Sumit talked about. The vehicle is designed for to run on a particular speed. There is an optimum speed in which the driving cycle designs when we do the type approval, we design the vehicle to run at that speed, which could be around 30, 40, 50. But when we get into a congestion or when we get express highways, that actually changes. So that is one of the very important things which nobody talks about, or somehow the vehicle manufacturers have always left it. And another is the maintenance culture. The vehicles which are old and they still continue to be on the road, so somehow their presence and how they are maintained in terms of
whether they undergo a periodic maintenance, whether they go to authorized dealers, etc., they also has an effect on the vehicle's emissions. And then is the numbers and the congestion game. The numbers discussion is very interesting because it is something like this, that you suddenly decide that, oh, okay, so we are getting clean vehicles, but 1,000 of clean vehicles is actually going to emit equal amount of pollution than as the old cars used to do. So if you look at the projections of the fuel quality, it is said that the PM 2.5 is going to go up by 25% in by 2030. And the numbers are also very interesting when it comes to the SOx and the NOx. The emission of the VOCs, which is the new kid in the block, because nobody used to talk about VOCs till a long time back, but their VOCs are actually a very, very important factor in this whole game. And they are also important because they help in creation of new particles and new secondary pollutants. So, and their numbers are also going to go up by another 30%. The okay. The challenge that we face is that more than 40% of the kerosene is lost. So kerosene in India is a subsidized fuel which is being provided to the low-income group areas, and nearly 40% of that fuel is lost, and this is documented. And these fuel end up being as adulterants. Now, till some time back, we had about 17 fuel labs in India, which were accredited by the Ministry of Petroleum and Natural Gases. None of them can actually tell you how much of the adulterant is mixed. They can tell you what is mixed, they can tell you it is adulterated or not, but they can't tell you how much the adulterant. So because the molecular structure of the adulterant and the fuel originally is so similar that they can't actually distinguish between them. We had done a study way back in 2002 when we had taken 21 liters of fuel, 210 liters of fuel from Delhi to IIT Dehradun in a Tata Sumo, and we got 200 liters of adulterated fuel. So we got, I guess, 10 liters, if I don't remember very well, 10 liters of each from each petrol pump, and they were only Delhi. So I'm still talking about metro, and I do not know what happens when you go just outside Delhi, like Meerut, Muzaffarpur, all these areas which are just Firozabad, which are not very far. The scrappage is an issue because you see what happens is when the vehicle standards are changed and new emission standards are brought into place, it does affect the vehicles up to an extent. You get better vehicles on the street. But you see, if you look at this two slides, you'll find that there are a considerable amount of old vehicles which are still plying and which will continue to ply on the road. Now the problem is that when a new emission standard is brought in place, the penetration of new vehicles in the vehicle fleet is not more than 3 to 5%. So which means that new vehicles will take some time, it will take some time for you to get the benefit of the new vehicles which are already on the street and are emitting less. One of the challenges that we feel is that there are still, so we had the staggered emission standards in India for a long time. So the BS3, then we got BS4 in select cities, around, I think, we started with 16 cities, then it went up to 31 cities, and then we had the similar fuel changes happening. But the problem is that by law, any vehicle that is manufactured and discontinued, the manufacturer is supposed to make the spares available for that vehicle for next 20 years, as per law. So that means that somehow, somewhere in the system, those vehicles are still running in the country. They may not be running in Delhi, and they may not be running in NCR, but they're still running. So which is a very, very interesting thing because we know now that the air pollution is transboundary. So if there is a large chunk of vehicles which are running just outside Delhi, maybe 40 kilometers outside, and they are heavily polluted and they are vintaged, So that pollution is somehow, depending on the wind direction, going to come to Delhi at some point of time. We talked a little bit about the PUC system. Sumit talked about it. When we were designing this PUC system way back in 2004, I thought it was a fantastic system because I had never seen anything like that. It had a camera, it had a computer and stuff like that. And I was designing it and I had to present it to Dr. Sundar. Oh, you did it? Yes. And I was designing this certificates in Word in my 2 minutes. Yes, I have seen the slip. And the point is that today, if you see, within 6 months, those were actually redundant. Those systems didn't even last for 2 months. It was so easy for people to come up with, the loopholes of the system to generate fake pictures, etc., that it doesn't last. But actually, the point is that sorry, that was my 9.5 minutes. So the point is that at the end of the day, it is these vehicles which are going to be polluting for a long, long time. You replace one vehicle with a BS6 vehicle, it is not going to make a lot of difference until unless we have a chunk of those new vehicles running on the street. So why does congestion happen? The congestion actually happens because there are a lot of people who move out to the low density areas, and then we have to provide transport, and most of the time that the transport that is provided is not good enough for them to connect to the hub of the city. And of course, when it comes to Delhi as an example, Delhi is such a fantastic example. You have high crime rates, you have high taxes, you have high ticket prices, you have high crime against women. It's perfect to have your own personal vehicle. So this is an unfair comparison. I call it unfair comparison because what I'm doing is also unfair. So what I've done here is that I've tried to compare the metro fare and DTC fare. I don't need to tell you how much your bike or car costs because I'm sure you have an idea of that. You see, I'm looking at a small displacement of 9.5 kilometers between Noida Sector 18 to Sarita Vihar. That takes 50 bucks for one person in metro and 20 bucks for DTC. Similarly, Janakpuri to Nangloi, which has a displacement of 11 kilometers, costs 40 bucks in metro and DTC 20 bucks. Now, you multiply this with 4 because an average car takes about 4. Or even if you take an auto, it can take about 4. So you multiply this with 4, it straight away becomes 200. So if we are talking about this as a public transport for the larger janta of the city who should be at the lower or middle income group, then this is a humongous price. He will rather use his car, which might be outdated, doesn't matter, he will just pay 20 bucks to the cop and he will still like to be happy to run his own vehicle. Oops. Okay. Now it's there. So why vehicular pollution is a serious issue? I think the vehicular pollution is a serious issue because I think it is beyond our perception that how mobile polluting device like a vehicle can actually keep on polluting around the area. I have been looking at some of the vintage cars which were brought in just day before yesterday for the upcoming Auto Expo in Noida, and some of them have come from Chhattisgarh. And they are fantastic vehicles to look at, but you like to look at them when they are stationary. The moment they start running, you actually can't see the vehicle anymore. So, okay, I'm sorry, it's taking more time, Mukta. It's my. Not being well. Yes, absolutely. So, one of the things which I wanted to talk about with the slide which didn't come was basically when we look at the load factors of polluting contributors in a city, we find transport has a role. But in that transport, one of the largest contributors are the heavy-duty trucks. You see, heavy-duty trucks constitute about 5% of the total vehicle park in a city. In Asian cities, it can go up to 7%, but in a lot of Indian cities, it can remain as low as 4%. But the contribution of emissions from the heavy-duty trucks is as high as 78%. Not only that, it drinks also nearly 70% of the transport fuel which comes for the city. Now, I will say that I have to skip slides, I'm sorry. Mukta is already looking at me, you know. So, is there a way forward? Of course, there is a way forward. I think urban planning is very key. Why urban planning is very key is because urban planning not only decides how your vehicles move, it also helps you in controlling whether your vehicle has to move or not. I mean, it regulates whether there is a need for transportation, whether there is a need for traveling at all. National approach is very important. I think the city-centric approaches have never been good. Whether it is fuel policy, whether it is air pollution control strategies, I think if we are looking at city-centric, they have never been helpful to us. In-use vehicles, I think the elephant in the room is the in-use vehicles. I somehow can't help not looking at them because they are such a huge number, and we still do not know how many vehicles are there because there is no registry of vehicles which are old and have been scrapped. So basically, in our database, vehicles are still alive, and you will find many of them actually alive in many far-flung areas. And last but not the least is the urban freight. I think urban freight is very important with the advent of Amazons and Flipkarts, etc. You find more and more urban freight encroaching into the traffic time in order to deliver your goods, etc. And there is a solution which needs to be brought onto the table, and it cannot be a ban, because for a city like Delhi, which doesn't actually produce anything, everything comes from outside, you can't just ban trucks. You need to find a solution to bring them otherwise. I guess that's all. Right, thank you.
Thank you very much. Amit, you should we just move up there? Amit doesn't have a PPT, so I'd request Sumit and Partho to sort of occupy the two chairs next to Amit so that when questions are being shot shortly after Amit finishes, they're all visible to everyone, more visible to everyone. Amit, go on.
Sure. So I'm not really an expert in air pollution like my two previous speakers, but the work I do has direct impact on air pollution. So when the first set of odd even trials were happening, and there was a lot of discussion around how much does transport contribute, is it 20%, is it 5%, is it 40%? So one is that if you look at last 7-8 studies which have been done in Delhi, whether it is the IIT Kanpur study or the Indian Institute of Tropical Meteorological study, the share of transport varies from anywhere 20% to as high as 45%. So depending on how you want to play the role of transport, you can pick and choose the study and establish your case. But that's only a small part of the problem. The bigger part is that we have still not understood the impact of transport on health. So air pollution and health. So when the first set of urine trials were happening, we said we wanted to further understand this PM 2.5 phenomena. And so we wanted to understand what is it that constitutes this PM 2.5. So Sumit mentioned, and Partha also mentioned about black carbon. We wanted to understand what is it, so what constitutes this black carbon. So we couldn't find any laboratories here which could test this. So we are doing some work with a PhD student in US, and we collected samples and took it to that university. It's a very kind of costly kind of experiment to do. But we found that there are heavy metal traces in this black carbon. And the dispersion of the black carbon is exponential if you move away from the source of where it is coming from. We also wanted to understand, and we put some exposure on commuters to understand so depending on the mode of your commute, what is your exposure like? And believe me or not, the results were very surprising. So results showed us that the safest vehicle in Delhi in traffic is actually an air-conditioned bus, followed by a bus, then a car, but again depending on what is the climatic season, because an air-conditioned car with air condition not working in winter is actually worse than maybe a three-wheeler. And so the reason why we're trying to understand was, on one side, we have to clean the air, and there's no two questions about it. And this will take some time, but can we reduce exposure? Because if you see some of these studies which say that about 75 to 80% of the exposure happens while commuting. So the question is, can we do something to at least, I'm not saying the only thing, but at least reduce the exposure? And then we realized, and while the whole odd-even debate which was happening was, but it only had 5% impact and this and that. But if you look at the reduction in travel time of people, actually their exposure went down by almost more than 50%. Because on one side you were taking 1 hour to commute, because of the decreased traffic density, you're not taking 30 minutes to commute. And while the air pollution has not significantly been dented, but your exposure has gone down by 50%. So I think that is something which you missed to play in the narrative of how odd and even. And there are ways in which you can do this even without going an odd even way, right? So that's one. Second is also, let's understand how Delhi moves. So Delhi has the highest usage of cars in the country, yet the portion is less than 15%, even if I take only motorized mode of transport. If I bring in non-motorized mode of transport, this percentage will be about 7-8%. So if I exclude walking and cycling, because we don't account it very nicely, so about 15% is what is the car share of overall motorized trips. Another 20, 22, 23, 25%, depending on how you count, is two-wheelers and other, two-wheelers mostly. So you have 50% of the motorized mode are car and two-wheeler. The rest 50%, 1/3 is Delhi Metro and 2/3 is buses and informal modes of transport. So that's how Delhi moves. Now, let's look. So if I am framing a policy, I should first try to say how the maximum can positively be impacted, right? Now, metro is elevated. It is even more good to travel in metro because you are above the road and you are in a way kind of not kind of getting it from the vehicles. But the problem with metro is that how do you access the metro? Because accessing to metro station is a big problem. Either you have to take three-wheelers, or you have to find a way, cycle rickshaw or something or the other. So that's one big component. And how do you access the metro? But there could be something which can be done to improve the access of metro. The second is the whole bus-based transport. And unfortunately, the share has been coming down drastically for last 6-7 years. We have been told that 10,000, 11,000 buses will come, but there have been almost 5 failed attempts to procure buses in last 4 years. So that's one. And then there is a whole question of what do you do with walking and cycling. And I am a cyclist, I cycle. The moment I see this AQI, I am forced not to cycle. Right? So that's one. So I think we have to look at this issue from a slightly larger perspective, because when the whole CNG conversion happened, everybody said that, and I'm not saying this conversion was not good, it was very nice. But did it solve the entire pollution problem? No. Because let us say if my vehicle is emitting X, and if I make some technological change, tomorrow it emits X by 2, definitely there's a benefit. But if the vehicle population goes by 4x times, then then you are not really getting any benefit out of it. So the question is, what is it that we can do? So I believe we can start looking at what is it that we can do immediately to start reducing the exposure. And that's where I think getting buses, getting metro, getting public transport, and giving priority to public transport. And while Delhi BRT may have not succeeded, but there are other ways we can give priority to public transport. So if we give priority to public transport, and if we can get these numbers right, I think a lot of exposure-related stuff we will be able to solve. Second, definitely, I mean, as Partha and Sumital said, that improving the quality of fuel and vehicle, and that is critical to it. But also understand that because of this so-called taxi network companies or the vehicle sharing which has come, a lot of disruption is also happening. So if you look at some of these modal shift which has happened to this Uber pool and Ola share, a lot of it is coming from public transport. So people are, because the quality of metro is so not that good, that people are ditching metro and coming on to, and which is again creating this whole issue of pollution, right? So can we also look at maybe a new technology like app-based buses? I mean, London recently launched an app-based buses, but we are still debating whether the app-based bus is legal or illegal and how do you do about it, right? So that is something. So to me, if something has to be done immediately, I think augmenting public transport could be the first thing. Second, improving the quality of fuels and vehicle. And I think there was statement which came last year, April, May, June, that we will go fully electric by 2030. I don't know how serious we are, but if we are really serious, then that would be icing on the cake. But again, fully electric 2030 means huge disruption from petroleum sector, the oil and gas sector, the incumbent ecosystem of vehicle manufacturers, and we are not talking about it. So I think a lot needs to be done, but that could be my suggestion to move forward. And just on this, towards the end of it, so we kind of co-created something called a Rahagiri Day. I don't know if you ever participated in any of them. One of the reasons why we created was to understand the impact of pollution on commute. And we did some experiments on the same set of stretch on a Sunday where there was no, where the vehicles were not blocked. We did some readings, both PM10 and PM2.5, and we did the readings with no vehicle. And we found the exposure, the contribution to by vehicles on that microclimate was as high as 50%. So that is something which we need to. So I'm saying air AQI is one, but exposure is number two, and we should also look at this as we move forward. Thank you.